So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is circle of strings. Again, difficulty is marked hard and accuracy is very less, but I'll be making this problem so easy for you all that after you understand the approach of this problem or the intuition to solve this problem, you all can write the code by your own. Like whatever I'll be explaining in the video, I'll be writing the same code. So basically, after knowing the intuition, the code will be like cakewalk for you all. You all can write it by your own. So let's see what problem is trying to like convey and how we can approach this problem. So given an array of lowercase strings, okay. If the strings can be chained together to form a circle, okay. A string x can be chained together with another string y if the last character of x is same as the first character of y, okay. If every string in the array can be changed with exactly two strings of the array, one with the first character and the second one with the last character of the string, then it forms a circle. So let's see the example for array ARR, which is for geek, rig, and caf. The answer is yes. How? It is given that the string of array can be chained exactly with two strings, first with the first character and the another string with the last character. So for last character is R, we can connect it with rig. Okay, let me take this example for geek, rig, and caf. Okay, it is given that for rig, geek, and caf. So we can clearly see that the last character R, which can be connected to this R. Okay, now the last character of a rig, which can be connected to this geek. Now the last character of K, which can be connected to this caf, and the last character F, which can be connected to this part. Okay, so we can see that we have chained the array and make a cycle. Okay, so I hope the question is clear. So basically we are given the array of strings and we have to find that whether the chaining is possible or not. So we can see in this example ABC, BCD, and CDF. ABC, BCD, ABC, BCD, and CDF. Okay, C, the last character of ABC, we can connect it to C. But what is the F? Is there any string whose starting character is F? No. So chaining is not possible. We can take one more example like BCD. So D, is there any string whose starting character is D? No. So it is also not possible. I hope the question is clear for you all. Now just bear with me till the end. After I'll like explain what is the concept or approach to solve this problem, then you all can write the code. Okay, so let me introduce one concept of Eulerian path and Eulerian circuit. So basically the Eulerian path and Eulerian circuit, it's the concept of graph, but this the concept is very easy. Like let me explain you. So what is Eulerian path? The path of edges that visits all the edges in a graph exactly once. It seems something we have seen in the question, like something like that, because again reading, the path of edges that visits all the edges in the graph exactly once means, for example, these are the edges which are given to us, this, and this. Now what okay, let me change that. Okay, these are the edges, this, and this. So the path of edges in a graph, the path of edges that visits all the edges in a graph exactly once means, or the path of edges in a graph that visits exactly once, and that only we have like read in the question, that we have to make the chain, we have to make it like a graph that we are visiting all the edges exactly once, and we have to cover all the nodes. Okay, so I hope the Eulerian path is clear. Now what is Eulerian circuit? A Eulerian path that starts and ends on the same node, and the condition is, Eulerian circuit condition is start double equal to end and visit all the edges once. I'll be explaining technically what is Eulerian path and how we can find and what is Eulerian circuit. So now let us see in this graph that, let us start with this node. Okay, so we can visit this, and this. Okay, in this we have covered all the edges, means this condition is like covered. Now we have started from here and reached here, so this point is also clear. So we can see that, we can say that this graph is Eulerian circuit. So let me write it. This graph is Eulerian circuit. Okay, now this graph is Eulerian path. Okay, so again repeating the conditions, Now the path of edges that visits all the edges exactly once means Eulerian path. Okay, so one thing I would like to tell you that when we are calculating the Eulerian path, so this nodes from which we are starting should be selected very carefully. Why? Because we can see that if we are starting from this node, we can visit this, and this. Okay, we have got the Eulerian path, means we have visited all the edges exactly once. Now we what if we start from this? By the way, this node has degree 1. Let me write this. We have started from here. We got the Eulerian path. Now let me start with 0. We are starting from 0. Okay, let me visit this. We have also completed and find the Eulerian path. Its degree is 3. What is degree? The edges connected to the particular node. Okay, we got the Eulerian path. Now let me start with this node 1. So 1, I can go here. Either I can go here or here. So let me move with this path. Now I cannot again repeat the path, because what is written in Eulerian path, visit all the edges in a graph exactly once. So you can see that if we are starting from this node, we can not visit all the edges. This edges is still remaining. So its degree is 2 and we cannot visit all the edges from this node. Okay, let me try it with 2. So we can visit this. Now two options, again go with this. So this edges and this edges are remaining. So from 2 also we are not able to visit all the path. Okay, so you are getting a clear idea that we have to be very careful while selecting the nodes. Okay, why? Because you can see that the node which is having odd degree, then only we have completed the Eulerian path. What if this do not have the edges, then also we are able to find the Eulerian path, because this has odd degree and this also become odd degree, because this is 1 in degree 1. So we can find it. Now let me reverse it back. So what is the condition for Eulerian path? So the condition for Eulerian path is the odd degree should be equal to 2, not greater than equal to 2, not less than 2. Then only we are able to find the Eulerian path. Now coming to Eulerian circuit, if any node is missing from here, okay, let me first iterate it. Let's start from this node. Okay, we can visit this and this, again come to this node. So we can find the Eulerian circuit. Why? Because start is equals to end and visit all the edges once. Okay, let's start from this and this, again come to 3. Okay, then starting from 0, this. Okay, we can find all the we can find the Eulerian circuit from any node we are starting from. How? Or we can say that why? It's just because every node has degree even 2, 2, 2, 2, 4. So for Eulerian circuit to be possible, there are 2 conditions that we have to check. There should not be any node which are having the odd degree, means odd degree is equals to 0. There should not be any node which is having the odd degree, as we can see here. Okay, it is clear. One more thing is, if according to the questions, let me introduce one more node here, 5. Now the question is saying that the question is somewhat similar like finding the Eulerian circuit, or we can say that Eulerian cycle. So let me start from this node. It is asked that a string X can be chained together with Y. Determine if the string can be chained together to form a circle. To form a circle with the given strings in the question, we have to visit all the nodes exactly once. And this is one component and this is one component, because these 2 components are not connected with each other. If we start from here, it is possible to visit all the nodes, all the edges, and come back to this starting node. But what about the 5? We have not visited this. So start is equals to end, we are getting in one component, but visiting all edges, or we can say that visiting all nodes for this particular question is not like satisfying this condition, second condition. So we are not able to find Eulerian circuit. So I hope the two conditions is clear. So connected means all the nodes in a graph should be connected. So I hope this is clear that by satisfying two conditions, we will be able to solve this problem. Now again, revising, like this is odd degree. Why odd degree? Because if any of the node has odd degree, then we can get to this. But what if we have to get out from this node? So it is not possible, because if we remove this, okay, let me start and this. So if it would have connected, means even degree, then this also even degree, this also even degree. So we are able to possibly start and end from the particular node. But if the node has odd degree, then it is not possible to start and visit all the edges and come back to the start only. So odd degree is equal to 0 must be satisfied. Okay, so if there are more than one components in the graph, so it is not possible to traverse, like there is no edges between this or this. So how you can start from this node and visit all the and come back to the start node only? So it is not possible. For Eulerian circuit, odd degree should be 0 and it should be connected. Again, while I am coding, I'll be satisfying only two conditions and the code will get passed. Okay, so let's take one more example, and you all telling me that is the Eulerian path is possible or not, or Eulerian circuit is possible or not. And by this example, you will be very clear that like what is the condition for Eulerian path, what is the condition for Eulerian circuit. Okay, so this node has 2 in degree, this has 1 in degree, this has 3 in degree, this has 3 in degree, this has 3 in degree. So you all can clearly see that if the odd degree is only 2, then only Eulerian path is possible. But odd degree here is more than 2, like 3, 3 and 3. So Eulerian path is not possible. And if the Eulerian path is not possible, then how can we find the Eulerian circuit? So Eulerian circuit is not possible. We can see that. Let me start from this node. Okay, this. What about this edge? We have missed this edge. So Eulerian path is not possible. Let me start from this. Okay, now this. Again, this node is not possible. Okay, let me start from this. Again, I have two choices. If I go there, okay, so not possible. This, not possible. So Eulerian path is not possible, and Eulerian circuit is also not possible, because if we are starting from this node, we can go out to explore all the edges. We can come back to to the start node, but again there is one edge, so we have to again move out. If it has even degree, then again we can come back, but it has odd degree, so there is no chance to come back. So Eulerian circuit is also not possible. Eulerian circuit is also not possible. Now again, revising the two concept, like odd degree should be 0, like there should not be odd degree, and the graph should be connected. In this question, we don't have to do anything with the Eulerian path, because we have to find the Eulerian circuit, means connected components, like starting from here and again coming back to here. Like we can see that R connected to this rig, G connected to this geek, K connected to CAF, and again F connected to for, where we have started. So we have to find the Eulerian cycle. So let me code. The code will be like very easy. So let me write this. Okay, so what I'm doing here is I'll be making one adjacency list, like from where to calculate the odd degree, like from where we can visit, like what are the nodes we can visit. So let me write this. Okay, from 1 we can, so okay, from 0 we can visit to 1. I'm giving just an example how we are getting the adjacency list, because I am writing each and every line of code and be explaining that what the part of code is doing. So 0 to 1, 0 to 3, 0 to 2, and 0 to 4. Okay, again coming back to 1 to 0, 1 to 2. Okay, coming to 2, 2 to 1, and 2 to 0. Okay, coming to 3, which is 3 to 0, 3 to 4, coming to 4 means 4 to 0, 4 to 3. So you can see by making the adjacency list, we can clear the odd degree or in even degree. So it has even degree, it has even degree, it has even degree, even degree, even degree. So this is how we are calculating. So U is equals to array of 0. Okay, v is equals to array of okay, not 0, I bracket 0, and here also I bracket a double r dot size a dollar I dot size -1. What I have done this? Okay, so let me explain you. I am not like worrying about what is the middle elements in the string. So I am only caring about what is the starting element of the string a, which I have calculated. Array of I means array of 0, which is abc, and that to 0th index, so a. Array of I means abc, and that to last index means array of I dot size -1. Array of I dot size means 3 -1 2, means this c is at index 2. So we got like a, and we got c, so we'll be pushing finally adj of u dot push back v, adj of v dot push back u. Okay, done. Now we have to calculate the like what are the connected components. We'll be making our count is equals to 0 and one visited end comma bool visited. Okay, I is equals to 0, I is less than size I plus plus. Let me traverse and call the DFS. I'll be explaining how DFS is also working, so just be relaxed. So if the array of I 0, okay, let me check it in visited vector, visited like data structure what I have initialized SITD. If visited of this double equal to false, means we have not visited this, so we call the DFS. We pass the character array of I 0 first character. Array of I means array of starting, and that to first character, which is 0, means array of I comma 0 means a. So DFS comma adj comma visited, and after exploring all the path, means if the path is connected, then at one go only it will be making visited all the nodes. Okay, then after like coming from the call, we'll be increasing our count plus plus. Okay, clear? So this is how we are calculating the count, like connected components or not. Now finding the odd degree. Odd is equals to 0. Now for auto I adj, I'll be explaining what I'm doing. Adj I dot first dot size. Let me write this condition. I'll explain like what I'm doing. So odd plus plus. Yeah. So what in adjacency list, what is stored here is 0 comma 1 comma 3 comma 2 comma 4. Okay, clear? This is char, this is vector of char, this is char, and this is vector of char. So what I'm passing here is I call adjacency list, and in I am getting this. I get every this and this. So what I'm doing here is again passing adjacency of I dot first, means I'm passing this 0 and asking adjacency to give me the size of this. What I'm doing, dot size, and checking that if it is odd by doing %1. Okay, this is the way to check the the size is odd or even. So passing this, asking that whether it is odd or even. If it is odd, then we are doing odd plus plus. At last what we are doing is, if count is greater than 1, means there are more than one components, or odd is not equal to 0, means, so what is the correct conditions to be satisfied? Odd degree should be 0 for any of the nodes. Okay, so odd degree is not 0, means there are some nodes which have odd degree, so we'll be returning 0, means Eulerian cycle is not possible. And if the two conditions fails, means there is no node which have odd degree and there is only one component, then finally we'll be returning 1, means it is possible to find the Eulerian circuit. So now let us write the DFS code. Void DFS, we are passing the character u, as here you can see that character, and then adjacency, then visited. This is character array of I comma 0. Now what I'm doing here, I am passing u in the adjacency, means passing u in the adjacency, this u 0, and asking that what are all the characters we can visit from u. So give me. So it will be stored in v. If visited of v double equal to false, then what I am doing, I am calling it for next, like passing v adj comma visited. Now it will traverse all the nodes. So okay, so let me explain how this recursion is working. Okay, from a we can go to b, and from b we can go to a. We can see that from a b we can go to any string that will contain either b at the starting or either a in the starting. This is the adjacency list. So let me call the visited vector for a, b, c, and for d. Now call for a. The recursion call goes for a, marked a as 2. At the starting we are marking it as 2. Now we are giving from a where all we can visit. We can visit to b. Now visit b, mark b as 2. Now from b where all we can visit a, but a is already true, so no need to visit. Like here we are checking, if it is false then only go to another call. So it is false, then go to c. C is not visited, mark c as 2 and call it for c. Okay, from c where we can visit b is already visited. We can see b is already visited, so no need to call it again. So d is not visited, mark d as 2 and d as call. Now again come back and come back. So this is how recursion is working. And finally we have calculated one component. Like at initially only we have marked all the elements as true, so the component is 1, and you can see that every element has degree 2. So we are passing the two conditions, like odd degree 0 is equals to 0, and there is connected components. Like here we have initialized count is equals to 1, means at one go only we have calculated all the components, so it is 1. So this is how it is working. Okay, so let me run this code. Okay, so it's running. Let me submit it. And I have passed this as ampersand because I don't want to make it the copy and making the copy again and again. So let me check. Okay, it's taking more time. Okay, so we can see that it's passed. All the test cases have passed. So I hope I have explained the code in an easier manner, and now after getting the approach to solve this problem, you all can write the code by your own. Okay, so thank you for watching and having patience. So thank you.